Hi class, we're going to move on to the third part of our experiment, and that is board C. So this is our board C, and we're going to go ahead, we do know that the length of this is 90 centimeters, so that's already written in for you, but just to show you once again that it is 90 centimeters, we will check the measurement just to be sure, and you can see right there it is 90 in red. So it is 90 centimeters, okay, and the next step that we have on our board just like that, and again you can see that it does go the whole way to the floor like it did with the last experiment, and so we are going to use the same height measurement because we didn't change our screws any, right? We measured this the last time, and again it comes right up to 20 there, so we can fill that number in. So that number isn't going to change the height from here on out. It only changed whenever we went from the short little board that didn't get off of our stand here. So we have the height or the length, and we have the height of 20 centimeters, and because we have those two, we are able to do the mechanical advantage for inclined planes, because we know that that is slope length divided by the height. So 90 divided by 20 is what we will be doing. So let me grab my calculator here. And we will do, okay, 90 divided by 20, and we get 4.5, okay? So 90 divided by 20, and that gives us a mechanical advantage of 4.5, okay? So that is the mechanical advantage that we get when we use the measurements, right? 4.5. Now we're also going to figure out the mechanical advantage using our forces, and we do know the force of the object, you know, the mass of our object, the R, we know that force, we already weighed that, so we can go ahead and put that one in. That is 2.15, so we had that taken care of the first time around, so that has not changed any, and we're going to go ahead and pull it up our ramp here, okay? So make sure that the board is secure. I'm going to spin it around so it'll work better for us. So set our car on here. Make sure it is at 0. We get a 0.655. 0.655. So if we're going to use 2 decimal points, we can round that to 0.66. Okay? So I'm going to write that down, and you can fill it in too. Okay, 0.66. And now we have both the numbers that we need to do our division to find the mechanical advantage using our forces. Force out, the R divided by force in, F. Okay, we know that formula from the very beginning class. So we have 2.15 kilograms divided by 0.66. Okay, and we'll do that on our calculator here. Okay, 2.15 divided by 0.66 equals 3.257. Okay, so our mechanical advantage is 3.2, and we'll round that 257 up to 26. 3.26. Okay, now that's a little bit off from our 4.5, isn't it? So if we actually take and divide and subtract that to see what our error is, 4.5 minus, what was it, 3.26? 3.26. We're getting an error of like almost 1 1/4. 1.24 error. So go ahead and in the space that it says off by, we are off by 1.24. Okay, so that's, man, we were off by 0.2 the first time, then we were off by 0.35, now we're off by 1.24. So we are really not doing better here. I feel like we're doing worse. Wonder what's happening here. Okay, so if you didn't, make sure you filled in your mechanical advantage there of 3.26, and then make sure you fill in that we are off by 1.25. Let's go ahead and we're just going to keep going. You're going to keep going, and then we're going to figure out things once we get to the end. Okay, so let's go ahead and do board D. Okay. I'm going to move board C out of the way here. We'll move in board D. Now my board D here is really tall. It's 120, and as I was getting ready for this video, I realized that my tape measure doesn't go the whole way to 120. It only goes to 100, so I'm going to go to 20 here. And I'm just going to put a nice big mark, okay, and then so that's 20, and then the rest of it should come out to be 100, so the 20 and the 100 will equal 120. You can see right there, turns out to be the 100. Okay, so the 100 plus the 20 here at the beginning of our board gives us 120. So just to kind of make sure we have the right measurement there. So we are dealing with a length of 120, and so we'll go ahead and put our 120 board down here. All right, so that board is 120, and you already have that filled in on your length, right? Because that was one of the numbers I gave you to make your hypothesis with. And we actually already have our height, right? Because we talked about the fact that it lands on the floor, and it is the same on the same screws, so it's the same distance up from the floor. So we know that the height is 20 centimeters. And now we can do that math. Again, 120, okay, because we know that slope length divided by height, and 120 divided by 20 is a pretty easy math problem there. And if you said, what is it, 120 divided by 20? Yes, you're right, it is 6. Because 12 divided by 2 is 6. And so 120 divided by 20 is 6. So our mechanical advantage here, what we're finding is 6 for this longer board, okay? Now, when we put our, when we move on and do this with the force, you know, using the weight R and the force N, the F, we're going to try to see if we can't get close to 6, right? That's what we're hoping our mechanical advantage is, because we're hoping that the measurements mechanical advantage is coming out to be the same as our actual experiment mechanical advantage. Now, so far, it hasn't really turned out the same. Like, each time we're actually getting worse. So, let's see if we get worse with this one, or if maybe we get closer. Okay? All right, here we go. So we know, we already know that the mass, the R of our bottle hasn't changed with the little car on it. It is 2.15, so that hasn't changed. Okay, and we're going to go ahead and set it right here. I'm gonna move the whole thing back just a little bit so you can see it. Set it right here. I'm gonna turn it on. Make sure we're at zeros there. We are. Just hook it up, and I'm just going to pull it straight up. Okay. And I'm going to do it 2 times here, just because that was really fast. Okay. I'm actually getting the same thing again. Okay. So our effort force here is 0.53. Okay, 0.53. So we have a mass of 2.15 kilograms, and our effort force we put in was 0.53 kilograms. So we can go ahead and do our division again, because we have the force out of 2.15, the force in of 0.53. That's what we were putting in when we pulled it up the board. And if we do that math with our calculator, 2.15 divided by 0.53. Okay. Get in here, clear it out from the last one. We have 2.15 divided by 0.53 equals 4. 4.06 is what we get, but pretty close to 4. And if we just think of it as 4, then our mechanical advantage is off by 2.06. Wow. So we keep getting worse. We're not doing very good with these. Why are we not doing very good with these? Let's take a look here at all of them. Okay, I'm going to bring those up beside me. Here are all of the experiment boxes. We can see that board A was off by 0.2, board B was off by 0.35, board C was off by 1.25, and board D was off by 2.06. Okay, so approximately, 2. So every time we seem to be getting worse, and there's got to be a reason for this. So I want to show you something, and then I want you to think about what we did a couple weeks ago. Okay, so let me show you something. This is our longest board. And this is our shortest board. Okay. Let's see if I can get them both on. Now, I'm not going to use the wheels this time, but I'm going to set this right here. Okay? I want you to notice, if I get it to sit there, what do you notice is happening? It's just sort of setting there, right? Whether it's setting, and I can roll it up, it's not setting on the car, but it just stays there. Other than rolling forward, it stays there. The weight of the car makes it roll forward. What happens if I set this here? Oh my goodness. Take that off. Let's try that again. If I set this on this board, like on this one that is really steep, our bottle slides right off. But on this one that isn't so steep, our bottle sits there. And if we think back to what we did a couple weeks ago, I think that might have something to do with it. And if you're thinking about friction, you are right. The reason our error continued to grow is due to friction. Okay? When we have a board that's steep, okay, there is the friction is not as great as when the board is shallow. Okay? And if you look here at the bottom of the page, there is some blanks that we need to fill in. And basically, what it is saying here is as an angle, okay, becomes smaller. Okay? So if we look at this angle here, okay, this is an angle. And then if we look at this angle, I'm going to pull it up here. This is a much smaller angle. As the angle becomes smaller and smaller, okay, then the friction becomes greater. There's more friction and more friction, okay? And friction causes error, okay? The reason why friction causes error is because it's holding it there. And when we looked at the mechanical advantage with just our measurements, when we would divide like 120 by 20, that is an ideal situation where there's no friction. But we know that in our world, because of gravity, there is friction. And the flatter our board gets, okay, the closer to being completely flat it gets, the more friction there is. Just like when we laid the bottle on it. There was lots of friction and it was able to just sit there. But when we laid the board on the short one, it slid right off. So there's not as much friction, and that is why the longer our board got, the more friction there was, so the bigger the error. So as the angle becomes smaller, okay, as the angle becomes smaller, there is more friction, and friction causes error. So our error increased. Okay? That's what happens in this experiment. And when you do the division with the slope length divided by the height, there is no friction involved there. You're just dealing with the measurements. But when we are actually doing the experiment and looking at the force we're putting in, there's a force of gravity pulling on that. And the flatter it gets, the more that gravity pulls, because the more and the more friction there is. Gravity pulls the same, but because of the friction, the flatter it is, the more friction there is. So that is why our error increased. It actually does make scientific sense for the error to increase. Okay? And the larger the angle, if we would do an even shorter one than this, we would probably come even closer to being on, because the bigger the angle, the steeper it is, the less friction there is. Just like we saw how the bottle slid off of A, but it didn't slide off of D. Okay, so that is the reason for our error to increase. So make sure you fill in those words at the bottom there. As the angle becomes smaller, there is more friction, and friction causes error. So our error increases as the board gets longer. Okay? All right, that is our experiment. Make sure you take a look at the other assignments for the week.